For number 53, we are told that a time-dependent force, F, as a function of time is equal to 8I minus 4tj newtons, where time is in seconds and it's exerted on a 2 kilogram object initially at rest. So here we have our object, it's just a box, and its mass is 2 kilograms, and its force as a function of time is equal to 8I hat minus 4tj newtons. Alright? And so part A asks us at what time would the object be moving with a speed of 15 meters per second. Alright? Well, let's first say that delta F is equal to mass times acceleration, right? And we already know that F, the only force that's acting on it is the one that we've described. And we can say that 8I hat minus 4tj hat newtons is equal to m times the acceleration vector, right? And if we divide by a, we can get the acceleration vector to be m, which is 2 kilograms. We can get the acceleration to be 4I hat minus 2tj hat. And now because we divided by kilograms, and newtons are kilogram meter per second squared, if we divide by kilograms, this cancels out and we just get meters per second squared. Right. Now, to get velocity, we have to take the integral of acceleration. And then this is also a function of time. We take the integral of acceleration, and we get velocity of time as a function of time is equal to, now some calculus, taking the integral of 4 gets you 4ti, and here you get t squared j, and velocity is meters per second. Alright, and now we're asked to find when velocity is 15 meters per second. Now this gives us a vector of velocity. So to find the actual velocity, you have to take the magnitude, and that is equal to the square root of both the terms, both terms individually squared and added together. So this is going to be meters per second, and then we get 4t squared plus negative t squared, right? And that equals the square root of 16t squared plus t to the 4th meters per second. And we're told that velocity, we want velocity to find the time at which velocity is 15 meters per second. So velocity of time equals 15 meters per second, right? We get 225. Check if this is in frame still. There you go. 225 cancel out the meters per second equals 16t squared plus t to the 4th. And then using a quadratic formula equation, let's move this up here and erase this cut. Alright, so then we get t squared minus 9 times t squared plus 25 equals 0. And so then t squared minus 9 equals 0, or t squared plus 25 equals 0. And this does not work out because you get imaginary numbers, so then t must equal plus or minus 3 seconds, and we only take the positive value because we're only taking the values that after 0 seconds, so then t equals 3 seconds. Alright. Alright, so then part B asks us to find the distance, or how far the object is from its initial position when its speed is 15 meters per second. Alright, so we already have our velocity equation, right? Vector velocity of t is equal to, move my notes, 4t I hat minus t squared j hat meters per second. Take the integral again, you get position, so r vector as a function of t is equal to 2t squared j hat minus t cubed over 3, oh, my bad, this is I hat, j hat, right, meters this time, because that's what the integral, or if you go back the other way, you'll take the derivative of the position vector and you get the velocity vector, right? Then we just want to find at 3 seconds, or because we found that v of 3 seconds, right, is equal to 15 meters per second, right? We want to find the r vector at 3 seconds. That's just easy. You plug in 3 seconds and then you get 2, 3 seconds. We already factored out our units here. So that's 2 times 3i, 3 squared I, minus 3 cubed, or 3j meters. And that would equal 18i minus 9j meters. There you go. Alright, so that's your answer for part B, because it just asks for the vector. We don't have to actually find the magnitude of that vector, which is what part C asks basically. So it asks what the total displacement is, and the total displacement is basically going to be at 15 meters per second, so that's again 3 seconds. Total displacement is just the magnitude of the position vector, and so that's just going to be the square root, same way how we found our 3 second answer. It's going to be the square root of the x and the y components squared, and it's going to be 18 squared plus 9 squared meters equals square root of, actually let's go straight to the answer, you guys can do algebra, is then equal to 20.125 meters. And that's your answer for part C. Alright, hope you guys all got it, and see you in the next video.